Hello again. This is the second part of Unit 7 in terms of coordination chemistry, and this section is going to deal with naming. And you know that big fancy word, nomenclature. Okay, so these slides give a set of rules in terms of how to do the naming. And I think what would be easiest is that if you were to read through this yourself, and if you have any questions, you can ask me. I will highlight some of the important things. Basically these slides are just like a tutorial, and there are about 10 examples to teach you how to name a variety of different complexes, and then at the very end we will look at some more information that you'll need for naming more complicated examples. So when we name coordination compounds, we should always name the cation before the anion. These rules are based on the International Union of Pure and Applied Chemistry's rules of how to name things. So it's like naming an ionic compound, except that this one's just a bit more complicated. Okay, so we name the cation before the anion, and then when you're naming the complex ion, you're going to name the ligands first, and you name them in alphabetical order. Then you place the name of the metal atom second, okay, and if the metal atom or ion is written before the ligands in a chemical formula, then there's some rules that you also need to follow. So I'm going to not read through everything because you can do that. So you just follow these rules, read through all of them, and there are quite a few, and then we'll get on to some examples. Okay, if we move on to the next slide, you will see there's some names of some of the common ligands. I've already mentioned that in the previous unit. When we looked at the representative ligands, there's a table that I asked you to remember. And these are just some of the ones that this particular slide highlights. We've also looked at the numerical prefixes in the previous section that I gave you in part 1 of this unit. Again, this just highlights what you need to know. Read through it carefully. Stop the video at every point so that you can understand what the slides are telling you. Then just a note which I haven't mentioned before is the name of a metal in an ionic complex. Remember that these metals here have their Latin names, which you'll need to know, that iron changes to ferrate, copper to cuprate, etc., etc. So just read through all of these very carefully. Stop the videos at any point so that you can read through them and follow all the rules accordingly. Okay, so we're going to do a couple of examples. I'm not going to do all of them with you, but I'll start with the first one. Okay, so how do we do this? Well, we need to look at this complex and we need to say, righto, I have a specific way of writing this. I see that everything is inside a set of square brackets. Okay, so these are the square brackets here. You can see them here and here. And everything inside the square brackets is called the inner sphere complex, which I've already explained to you. The chlorides are outside of the coordination complex, and the ammonia ligand, this is the ammonia and this is the water, they are inside the coordination sphere. Alright, now remember that ammonia and water, their names change when we name them. So ammonia becomes amine, A-M-M-I-N-E, and water becomes aqua. You need to look at both of those and decide for yourself which one in terms of alphabetical order would come first. Obviously, the amine is going to become first before the aqua. AM is before AQ. All right, so how do we go about naming this thing? Let's put up the solution so that you can see what happens. All right, so I've basically explained the first 2 points on the list over there. So I've explained this one and explained this one. In this case, you will see that the complex is electrically neutral, and so it has an overall charge of 0. There are 3 chlorides associated with one complex, and each chloride has a -1 charge. So therefore, the charge of the species inside the square brackets must be +3. Okay, so from the charge of the complex and the charge on the ligands, we can calculate the oxidation number of the metal. In this case, we see that the oxidation number of the chromium is +3. Now, how do we name it? Well, we have 3 ammonia groups, so that becomes triamine. Okay, we have 3 water groups, that becomes triaqua. So the ligands have gone first. Okay, then we name the metal chromium, and then we put its oxidation state in Roman numerals, in brackets, and then we put the anion at the end. Notice you don't have to say trichloride at the end, it's simply chloride. Okay, I will get to something which would be a little troubling for me, and this is where we have the 2 vowels together over here and over here. There is a convention which allows you to change the tri to tris. So go back to the previous unit, and you will see that under tri there was and bi actually, there was another option where you could say bis or tris. It's generally better, in my opinion, to change, instead of saying triamine, we say trisamine, trisaqua. It's perfectly acceptable and perfectly legal for us to do that in terms of the naming conventions, and it's actually better because then you don't have these prefixes against a ligand that has 2 vowels together, which doesn't really sit right in terms of the English language. Okay, we have another example. This one as well, you need to work carefully through it, and you'll see that again, look for your square brackets. You see them here. So this section here is the cation, this is the anion. Okay, and again, this tells you the number of anions outside of the coordination sphere is going to tell you what the charge is of this cation. Bromine, we know bromide has a charge of -1. There are 3 of them. So that means that the charge on this thing is +3. That's the cation. Okay, +3. However, there's a chloro sitting inside here, which is also a negative charge. So then this should tell you what the oxidation number is on the platinum. Okay, so here is the solution. We have 5 ammonias, so that becomes pentaamine, chloro, platinum 4 bromide. Okay, so you will see that from this point of view here, this totals -4. Therefore, the oxidation number on platinum is +4. And that's where I get this from here. Okay, and the 5 ammonias becomes pentaamine, chloro, platinum, bromide. Right, there are a number of other examples that you can go through on your own. Read through carefully. I don't want to keep you too busy listening to my voice going on and explaining them, but if there are any that you don't understand, then you can ask me, but these solutions are quite extensive, and there are many more examples. Like I said, there are 10 of them in the slides. You will see as well the use of the bis and tris in these examples. Okay. If I continue to the next examples, there's these ones along with their solutions. There's this one. Becomes a little bit more tricky now because these guys here are anions. Okay, this is an anion. All right. Now, what happens is the rules are very clear in terms of how you name anions, and I will leave you to work through those on your own unless you have any specific queries. Then you can ask me, but they come with lots of practice. That's why there's so many examples. So here is this solution. You will notice in the case of an anion, the words ATE go on the end. That is to indicate that the complex itself, the coordination complex, has a negative charge. Don't forget to stop the videos at any point to read through it carefully and to try and understand the solutions that are given. Okay. Here is another one with its solution. Number 8. That's a neutral complex with its solution. In this case, we don't change the name of the metal because it's in its elemental form. Okay, 2 more left. There's this example that's quite hectic. You need to think carefully about this one. Work through the solutions, recognizing each of the elements present and the ligands present. And then the last one, where we have 2 complexes, one is a cation, one is an anion, and it tells you how to name those complexes accordingly. And then there's a bonus one, which I'll leave you to practice on your own. It's quite a tricky one, and good luck with that one. A last little bit of theory for you is that sometimes we have elements that will bridge 2 metal centers, and there's a way to deal with those. They are denoted by a prefix called mu, and if you have a look at this one, it gets named before anything else. So the oxygen that's here, there is the oxygen, you can see it's bridging this complex to this complex here, and we use the prefix mu by writing the Greek letter mu. The oxygen is the one that is bridging, so it becomes oxido, and then there are obviously 2 identical complexes, which is the pentaamine cobalt 3, and it'll then be bis because there are 2 complexes, pentaamine cobalt 3. Okay, the use of bis, tris, and tetrarchus is generally when the name of a ligand already has a prefix. We can use this extra convention, and also, as I've explained previously, we use bis, tris, and tetrarchus if 2 vowels are put together with one another. It makes it a lot easier. Each person has a personal preference, and it's well within the IUPAC rules. So go ahead and practice the examples that I've given you in terms of naming, because in the assessment for Unit 7 there will be plenty of examples of how to name the various ligands. Good luck, guys.